Hello, everyone, and welcome to the channel of Mathemagic Nerds. So, today we will be focusing on the topic transpose of a matrix. So, I will just explain it in the simplest form. For example, we have a matrix A, and we know it well that in general, in representation, it is Aij with the order, right? Where m is the number of rows and my n is the number of columns. So I hope so that you have gone through my previous lectures as well, so that the upcoming lectures will be relatable. So now, what do we have in transpose is that if my order is m cross n and the transpose is denoted by with a, and we just put the sign of a dash, kind of a dash over a. So this denotes my transpose of a certain matrix A. Now, what the catch here is that if the order of A is m cross n, as I've written just above, the order of transpose will be in such a way like I will just have to interchange both of them. My m will go here and my n will come here. So, what is it? It is n cross m, isn't it? So, that will be n cross m. So, the resultant matrix, that is after we transpose it, the order will be m cross n. So, I will just give an example so that it will be clear that how do we find the transpose. For example, I have a matrix A which has elements like 3, 5, root 3, 1, 0, and 1 by 5. So what is the order here? We have 3 rows and 2 columns, so it will be 3 cross 2, isn't it? So the first and foremost step is to just focus on the first row. So the aim here is that the first row will be changed into my first column. So this will give me my transpose. So I will just write it down here. So my first row becomes my first column. Okay, so we are done with the first row. Now we will just focus on my second row. It is root 3 and 1. So my second row will become my second column in my resultant matrix. So what is it? Root 3, 1. Now let's just focus on my third row, which is 0 and 1 by 5. So my third row will become my third column in my resultant matrix, which is my transpose. So I will just write it here as 0 minus 1 by 5. So this is my resultant matrix. And as you can just observe here, what is the order? We have just interchanged it. It is 2 cross 3. So this is how we generally calculate the transpose of a matrix. So let's just focus on another example just to clear the definition. So this is the matrix A which is given to us, and we have to find the transpose of this matrix. So let's just focus first of all on the order. We can see that we have 3 rows and 2 columns. So the order of the given matrix is 3 cross 2. So the main agenda is to focus on the rows of the matrix A one by one and just to convert them into the respective column. So my first row is 1, 2. So I will just write it my resultant matrix like this. Now my first row is 1, 2. So I will just turn into my first column in the resultant matrix, that is the transpose. Now let's just focus on the second row. It is 3, 4. So in my resultant matrix, it will be 3, 4. Now what about the third row? It is my 5, 6. So I will just turn into my third column of my matrix, that is 5 and 6. So just again, for the sake of completeness, I will just focus there. What is my order? It is 2 cross 3, which is nothing but the order which we get when we interchange the orders. So before we proceed to the further lectures that are symmetric and asymmetric matrices, it is important that you must also know the properties of the transpose of a matrix. So the first and foremost is that if I take the transpose of a matrix A and if I take the transpose of the resultant matrix, it will just give me the actual matrix which we have started with. So let me just give an example. If this is my matrix A such that these are the entries in the given matrix. Now what is my transpose? All we have to do is to focus on the row one by one and we will just turn it into the respective column in my resultant matrix. So this was my first row and let's just focus on my second row. It is 2, 0, 4, 0, 2 as my second column in my transpose. So let's just find out the transpose of this newly calculated transpose. Now again, we will just focus now on the rows of my resultant matrix. It is 3, 4, so this will become my first column as well. Now what is my other? it is root 3 2. So this will be root 3 2 will become my second column. Now lastly, this is my 2 0. So this will become my 2 0. So if you will just observe that what is my A and what is my A dash dash, it is pretty evident that these two matrices are the same. So this property just shows that if we take the transpose of a matrix A dash, it will just in turn give out me the original matrix. Now, if we focus on our second property, which says that if I add any two matrices A and B, and if I take the transpose of it the resultant must be equal to the sum of the transpose of each of my matrices. So again, I will just pick up an example. So let A be this, and let my B be 2 minus 1, 2, 1, 2, 4. Now just focus that because we are dealing with the sum of matrices, it is important that the order must be same, and the order is, what is the order? It is 2 cross 3, and it is 2 cross 3 here as well. So let us just first of all calculate the transpose of my matrix A. So we will just focus on my first row. So this will become my first column. I hope so this is clear conceptually. Now let us focus on my second row. So this will become my first column. So this is my transpose. Now what will be the order? It is 3 cross 2 because we have 3 rows and 2 columns. Now let us calculate the transpose of B. Again, we will just focus on my first row. So this will become my first column. And what is my second row? This will become my second column. So the next agenda is to add both of these. So since we have to add A dash and B dash, we have just calculated it above both of these values. Now, because in addition, what we do is that we simply add the corresponding elements. All these, lectures are available in my playlist matrices in case you have missed out any of the points that I'm mentioning here. So we will just simply add each of the corresponding elements like 3 plus 2, 4 plus 1, and so on. So this is the resultant matrix which I have got. So I'm not showing you the, I'm not writing it and showing it to you because these things are already discussed in the previous lectures. So this is my resultant matrix, that is A dash plus B dash. Now what we have to calculate is A plus B. Now we are given A and B. So again on a similar basis I have calculated my A plus B simply by adding the corresponding elements. Now what is my resultant matrix? This is my resultant matrix. Now what do we have to find? The transpose of this resultant matrix so that we can just compare this to the sum of A dash and B dash. So what is the transpose of this? We will just simply consider the row and we will just turn it into my first column, and same with my second row as well. So this is the resultant. Now just focus assuming that this is my second equation. So if you will just compare this and assuming this as my first equation, it is evident that both of these matrices are same. Hence this property is true.
So the next property is about multiplication of two matrices, and what if we take the transpose of the product. So that will be equal to the transpose of the second matrix, which in my product, which I've written here, multiplied by the transpose of my first matrix. So as an example, I have considered these two matrices. Now let us first check whether the product AB is defined or not. So what is the order of A? It is 3 cross 1, and if you will focus, this is my column matrix. Why? Because it has a single row. It is important that you just recall the previous facts and theories so that you will remember everything by the end of the chapter. And what about this? This is my row matrix. Why? Because it has a single row. So what is the order? It is 1 cross 3. Now to check whether my product is defined or not, you just check the last number of my first matrix and the first number of my last matrix. We ignore these two, so my resultant will be 3 cross 3. Now because 1 is equal to 1, my AB is defined. Okay, so now what we have to do, we have to find the product AB. So we will just simply write it side by side. And what is my product? It is the first, we will focus on the first row, and then we will multiply the consecutive elements in my row in my matrix B. So what is it? 2 cross 1 minus 2 3, and this is minus 2 multiplied by minus of 6. This is my 4 cross 1, 4 cross 3, and 4 cross minus 6.
The third row will be my 5 into 1 and 5 into 3 and 5 into minus 6. So just simplifying the values in my matrix. So this is the resultant matrix. Now what our next agenda is to find the transpose of AB, and we know that what we do, we simply turn my each row into my column in my resultant matrix. So this is the resultant matrix which I get after I take the transpose. Now we what we need to calculate is the product B dash and A dash. Now for B dash, my row matrix will become my column matrix, and my column matrix will become my row matrix. How? This is the my B dash and A dash. Now as far as the product is concerned, this is my AB, this is my B dash and A dash, and I have written it side by side, and then again I have calculated the product. The first row will be multiplied with each element in my row n. So this is how we just simply multiply the matrix. Now if you will focus on this value, let it be 1, equation 1, and this be my 2, if you will focus that these two values are same. So this is how we basically can see that these are the properties of my matrix in transpose basically. So now the last property in the transpose is that if I have a k here is my scalar. A scalar can be any number. And if I multiply it by my matrix B, and if I then take the transpose, so that will be equal to my transpose B with the scalar as my product. So first of all, again, I will just start with the matrix B as an example. So this is my example. And if I'm going to multiply it with a scalar B, a scalar K, so this is my general representation. And we know that in scalar multiplication, the scalar is multiplied to each entry in my given matrix. So this will be the resultant matrix where I have simply multiplied my K with every element in my matrix. Now, if I will just find the transpose of it, we know that the row will become my row. Like this is my second row. Okay, so this will be my KB dash. Now, what about my, sorry, this is my KB and then the transpose of it. Now, what about KB dash? Now, this is my K. Now, what is my B dash here? I will just write it down here. It is nothing but my row will become my column and my second row, which is this will become my second column. So this is my B dash. Now, I will just write this down here. Now, if you will just focus, let this be again my second equation and let this be my first equation. Now, in this equation, in this one, I will just take out my k and I will write down my resultant matrix. It is 2, it is 1, this is minus 1, this is 2, this is 2, and this is 4. So just compare these two values. Now it is pretty visible that these two are equal. Hence, this is my last property in transpose. Now now we know the definition of a transpose and a few properties that might be helpful in our future lectures. So we will now focus on symmetric matrices and skew symmetric matrices as our next lecture. That is it for today. Thank you.